Welcome to today's webinar presented by Meopar and Coastal Action. The topic is Microplastics in Atlantic Canada. My name is Laura Avery, manager of Meopar's training program. The Marine Environmental Observation, Prediction, and Response Network is a national network of academic researchers, students, government scientists, and partners working together on marine issues. Coastal Action is a charitable organization that addresses environmental concerns within the South Shore region of Nova Scotia. Our presenter today is Ariel Smith, Coastal and Marine Team Lead with Coastal Action. Ariel graduated from Concordia University with a Master's of Environmental Assessment and has 5 years experience in project creation, leadership, and data collection focused on the issue of marine debris and microplastics. Over the past 4 years, Ariel developed and led the Atlantic Canada Microplastic Research Project, which she'll tell us about today. Ariel is chair of the Microplastic Working Group, which was formed during the second annual Clean Ocean Summit in Halifax, Nova Scotia. In addition to microplastics research and education, Ariel created Coastal Action's Ocean Friendly Nova Scotia program, and this program works with businesses across the province to eliminate single-use plastics at their establishments. So welcome, Ariel. Just a few housekeeping items before we begin. Today's webinar will be recorded and you'll receive a link to the recording within about a week. The presentation will take about 40 minutes and then Ariel will be available to answer questions. If you do have a question, please enter it in the Q&A box, which you'll find at the bottom of your screen. For those of you just joining us, welcome. Ariel Smith will provide an overview of Coastal Action's Atlantic Canada Microplastic Research Project. Ariel, over to you.
Great. Thank you so much, Laura, and thank you, Meopar, for inviting myself and Coastal Action to present on our research on microplastics over the last few years. I want to first acknowledge that although we're coming from all over the place, I just saw a note that someone is tuning in from Tunisia. I am located in what is now known as Halifax, and want to acknowledge that this is Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. So to provide an overview of what I'll chat about, I'd like to give an introduction to who we are at Coastal Action, just so you know a little bit of our background, the areas in which we work, and kind of our geographic scope. I'll get into a couple microplastic types and terms so that we're all on the same page, and then move into the project overview. So looking at our project sites, the methods, objectives, and then our results, specifically focusing on the 2018 surface water data. So we're looking at quantity and types, as well as chemical composition and the results from there. We will also share some on the Shoreline sediment method. So I have some data from that. However, we're waiting for our full data set, but I want to share the methods we used. And I'll provide some concluding remarks, what we're doing now. This is very timely as we're wrapping up this microplastic research, but the work continues and we have a lot of exciting things coming in the realm of microplastics and marine debris research. And we'll leave some time for discussion and Q&A. So Coastal Action, we're now in Mahone Bay. We've been located in Lunenburg for several years, kind of back and forth between the two places on the south shore of Nova Scotia. And we're celebrating, just this past year, we celebrated 25 years. We were established in 1993. Our mission is to restore and protect the environment through research, education, and action, weaving those three components through our four themes, which are listed here: watersheds and water quality, species at risk and biodiversity, climate change and education, and I lead the coastal and marine team. So it's important to note here our perspective and my perspective. As a small community-based organization, we have an interesting local experience and knowledge. And we've worked on the South Shore, and we work with other partners that have similar experience in their locations. And I think that's very necessary for microplastic research, because you start to understand the region in which you live and work, and you know the people, the activities, and that kind of thing that help link towards source and future communication efforts. So the two types I'd like to go over are primary and secondary microplastics. And I'm sure many of us have heard these terms before, but I'll review them, as well as a couple size classifications, which I'll be referencing throughout the presentation. Primary microplastics are manufactured at this tiny little size. So we have fibers, microbeads that we all know and hate, which are found in cosmetic scrubs. Um, they have been banned in Canada. However, they can be found still in people's homes because it takes a long time to get those off the shelves. Microplastics can also be tiny pellets and industrial nurdles, which are used to melt down and used for our larger plastics like tables and chairs. Secondary microplastics are the larger items, which I mentioned, as well as single-use plastics, commercial plastics, packaging that break down into microplastics over time due to sunlight exposure, wave action, and weathering. And you can see that through these microscope photos available from Clear, some of the fragments, foam pieces, threads that are found in the marine and aquatic environments. So often we hear the term microplastics over and over again. What is being referred to in the literature and from a research point of view is our microplastics are less than 5 millimeters in size. However, you can find plastics in the environment and through our research that are larger than that. 5 to 25 are usually classified as mesoplastics, and then macroplastics are anything greater than that, often named items or things that we can detect, like a lobster band, a lobster tag that would come through the sample. And then even tinier than those microplastics are the nanoplastics, which are impossible to see with the naked eye and often need quite a strong microscope to detect those. So the project is called, as Laura mentioned, Atlantic Canada Microplastic Research Project. It has been funded by Environment and Climate Change Canada's Atlantic Ecosystem Initiative, and the purpose is really a baseline understanding of microplastics in the region, looking at 3 communities of Atlantic Canada, and utilizing this data to better inform the conversation around solutions that have to do with plastic pollution in the region. So context and region specific. So it's a great time to be presenting about this, and I'm very grateful to Neopar for the invite as we're kind of wrapping up this 3-year project, communicating our efforts and our results, and determining what are the next steps and how can we utilize this data in a really effective way. So here are our project partners. We have been lucky enough to partner with Dr. Max Lebaron and her team at CLEAR over the past few years. Max has been the chief academic advisor, and she leads a civic laboratory for environmental action research, which is based at Memorial University in Newfoundland. So she has been part of leading our training, helping with our project development, providing the sampling design and protocol, and really allowing me to better understand this microplastic issue over the past 4 or so years. Clear and her team also have done sample analysis. So all of the samples we've collected, surface water and sediment, have been sent to Clear for analysis. And as I mentioned, our partners are also community-based groups. So ACAP Humber Arm are on the western side of Newfoundland. They've collected the data, helped us with project development. And Clean Annapolis River Project are on the Bay of Fundy side of our province in Nova Scotia, and they have also collected data at their sites, as well as providing some mapping and communication efforts in the past year or so. And as I mentioned, Environment and Climate Change Canada is our funding partner. So as an overview, and for those of you who aren't quite familiar with the region, I wanted to provide this map just to see where sampling took place. So even though we're looking at a regional perspective, we really are only at 3 sites. And so keeping that in mind, that a lot more data is needed to better understand what microplastics are doing and how many there are in our region, we need more data collected. So this is a preliminary look, a baseline understanding of the issue. But we're on coastal action sampled on the Atlantic coast of the province. CARP is on the other side, Bay of Fundy sampling in the Annapolis Basin, and I'll show site-specific maps in a moment here. And ACAP Humber Arm are on the western side. They're located in Corner Brook, Newfoundland. So kind of the crux of this whole project has been utilizing the low-tech aquatic debris instrument, or the LADI Trawl, that was developed by Civic Lab and Max and her team. So there's the manual, front page of the manual there. And we really now have been converts, and I preach the good word of the LADI Trawl to anyone who will listen, because it has been extremely valuable in how we collect microplastic data and how it can be accessible to so many more groups with limited funding or resources or time. So what has been awesome about this is we could build the trawl ourselves. We use mostly hardware store materials. We could repair it ourselves. We do have a scientific mesh, which was ordered through a scientific body, which is the net here, the 333 micron mesh, so that we're collecting those tiny pieces of plastic. But it was very easy to use. It's around $600 max to build, instead of the Manta Trawl, which is kind of the standard for microplastic sampling around the world, which is around more like $5,000. So as a community-based group, we're happy to have this. I'm happy to be able to build it and have our partners build it themselves that they can now use for years to come. Another really important part was having the training attached with the equipment. So Max came to visit us in June of 2018, and she actually went through how to utilize the trawl, what is needed for sample processing and bottling, and all partners were then confident enough to go back to their sites to collect data and for the project to be a success. That's all of our partners in Bridgewater, in Nova Scotia, where we did our first sampling and the training in June of 2018. This is to really point out that the boat use, as you saw in the previous photo, we have a whaler at Coastal Action, and we built an arm to make sure our trawl was just outside of the wake. But our partners at Carp, they just had a much smaller boat with an outboard motor, and they were able to do the same. So also have an arm to make sure the trawl was outside the wake, and the trawl is very light and easy to maneuver, so you can pop it on board and do sampling very easily. I wanted to show this video just to show how the LADI Trawl kind of moves and skims the surface. The arms kind of keep it buoyant, and it is able to kind of bounce on top of the water and collect surface water sample. We're at the mouth of the LaHave River, so often we encountered really choppy conditions, and the LADI Trawl was still able to, maneuver that. This was a pretty nice day, so it was easy to skim the surface. But depending on the conditions, you just have to slow down and record the speed. So mentioning more about our methods, we decided to go with 6 trawls per site. So we did 20-minute trawls at about 5 knots, recording that information during each trawl. So I will show on the map how that looks, but that's our method. And once the sample was collected, we had 6 of these. Because we had 6 trawls, we had 6 caught ends at the end of the trawl, which we could take off, and that was our sample. We ended up doing sampling processing on shore, although you can do it on the boat depending on your space. And we sieved through that sample using, again, a fine mesh sieve. And often the seaweed in the organic material is rinsed before it's bottled, just to make sure that we're not sending too much organic material. But once that is bottled, then making sure that fingers and anything that touched the sample are rinsed back into the sieve, and we collect everything that was in that sample. You'll notice we use these Gatorade bottles. We're using fresh water to rinse the sample. We had these bottles because of Coastal Action's water quality and watersheds work already, and we found out they were really easy to control the sample. We didn't want to lose any of what we had, and although it takes a bit of time, it was pretty effective and pretty efficient. for our use, and that's what we went with. So mentioning the sample sites and the 6 trawls we did per site, I'll just get you to kind of ignore the categories and the amounts for a second, as I'll have that in much more detail in the next slides. But we had, at our location at Coastal Action sampled at, we had 5 sites that we were able to collect data at. As I mentioned, we collected data at in the river itself, so that's our freshwater site that we did training with Max at, and then we had a few kind of across the region, dependent on like many different factors, where it was accessible to sample. We also really wanted to collect surface water data adjacent to our shoreline sediment sites, so I'll make a note about that later on as well when we discuss the sediment sampling. Our partners on the Bay of Fundy side, they mostly had their sites in the Annapolis Basin. As we're kind of looking at this data and doing some reporting, it's really interesting to note the different activities that are happening in each region. So for instance, it is noticed that there are known kind of fishing dumping grounds, or in past historic dumping grounds of fishing gear. So we're seeing a lot of thread in those areas. And then we have sites kind of coming into the Bay of Fundy itself. So more information will be available on this. And we have a report that is on our website right now. And then lastly, our Bay of Islands partner, they sampled mostly, they were able to do more samples, 8 in and around Humber Arm and the Bay of Islands. And they had quite a few higher levels of microplastics found as well. So the analysis itself is done by Claire and her team, Claire and Max's team at Memorial University. I was able to hop in a couple times over the past couple years, but this last fall, I took these very poor microscope photos, but just as a kind of a view of what is being found. And over the course of that week, I was able to kind of delve into the visual analysis portion of the project, which I was very thankful to be able to do to get that side and that information. So I'm looking at a sediment sample here from Western Newfoundland, and a couple plastics were found. So, I mean, I found a lot of plastics actually, but here are a couple photos of it. On the left-hand side, it looks what probably is a shaving off of a bucket, and I found quite a few of those. So that will be kind of cross-referenced with potential contamination, or making a note of that in the final data set from the team. And then on the right side, it looked like what was a red paint chip. So that was noted as a fragment as well. So those are kind of an example of the categories that the plastics are put into. They're quantified as well as categorized. They're also divided in between size classifications, as I mentioned at the beginning. So most of what we're seeing are microplastics, so those less than 5 millimeters in size, and those in the purple bars here. And just so you can kind of see how they're delineated between size. And making a note that these don't account for any statistical analysis. It's purely just a representation of size classification in this graph. And here kind of delves into those categories that I mentioned. So all areas for 2018 surface water data is represented here. So all of the sites that were collected. We have most of what is being found are fragments. So this could be really anything, hard plastic fragments. They can be flexible. It's hard to determine what exactly the source might be, but sometimes it's evident. And then we have threads. So this is often from fishing line or rope, nylon threads, different from microfibers. So fibers are categorized as usually synthetic fibers, or from our clothing and fabrics and that kind of thing. So the delineation between those two types. And then we have foam, film, micro beads, pellets, and then, as I mentioned, named items or macro plastics that are found. This is broken up per site, so you can see, obviously we're working with total plastics are different, so keeping that in mind. No stats have been done on this, just visual representation of the categories, but most of it are fragments and threads with some film and foam. So those are most of what is being found. It's good to see not too many microbeads are in the sample, and a lot of the named items that were found were at the Newfoundland location, some fishing related gear, sewage outflow, and that kind of thing. So the next step after we did visual quantification and categorization by clear, part of the project, we wanted to have some portion of our sample have FTIR spectroscopy done on the sample. So FTIR uses optical spectroscopy to determine the chemical composition and is assessing the bonding of each material. So we went through Surface Science Western, which is based out of the University of Western Ontario, to have this analysis done. And it really is the next step in helping us identify potential sources of the plastics and the plastic particles. And then once we know more about the chemical implications, really knowing more about the impacts that these microplastics can have. So an overview of these chemical composition of the particles. We had our 2018 surface water data. All particles that were found by CLEAR were sent to Surface Science Western for analysis. And here is kind of a overview of what was found at all study sites. So most of what we're finding are polyethylene and polypropylene, which aligns quite well with our understanding of the categories. So we have polyethylene, which is the most popular plastic worldwide, and those are often fragments of larger plastics. And then we have polypropylene, which connects with the threads that are found. So often polypropylene is from nylon threads, fishing gear, nets, fishing related materials, some polystyrene and PET as well. More information on all of our FTIR analysis is in our final report, which will be available next week on our website. We currently have a report that shows all of the categorization of plastics, but we just kind of analyzed our FTIR results and want to share that as well. So as an example, just a closer look at chemical composition, I just want to look at our sites, so Coastal Action sites, which sampled at the LaHave River, LaHave Islands, and Lunenburg. Just to get an overview, we have so polyethylene, polypropylene around the same amount, 16%, and then polystyrene. We do have some particles that were anticipated to be plastics, may have been organic material. So there are a couple that are organic. There are some that are uncommon commercial plastics, and in our final report, that 11% is actually broken up, so you can see the specific chemicals of what the uncommon commercial plastic category refers to. And I really just want to kind of wrap up this portion discussing the FTIR results to mention about the impact. So we are learning so much more as an organization, as a research community, on what is needed to better understand chemical implications of microplastics in aquatic and marine environments. And I'm just along with the rest of the team and many others who are learning as we go with that new research. But a couple important notes about potential impact is that contaminant levels can grow over time within a species. So a juvenile fish may have a lower toxicity level, but as it grows into an adult, that can grow as well and bioaccumulate over time. And then there's also the potential for biomagnification. So microplastics, you know, in a small species, we see it in zooplankton. If that's eaten by another species, it can grow and biomagnify up the food chain. So microplastics do have the ability to adsorb organic materials, persistent organic pollutants that are already in the environment. We know that microplastics inherently have chemicals because they're oil-based products, but they also can kind of become this little super pellet that moves through an environment, and that will have implications for the habitat, species, and the environment as a whole. And then obviously we are at the top of that food chain, so there are questions around human health, and that research is being conducted right now. So that wraps up an overview of the surface water analysis, and we do have a full data set that was completed before the COVID-19 pandemic, so we're happy to be able to report on the quantity, the types, as well as the chemical composition for all samples and sites that we conducted in 2018 for surface water. We are waiting, however, to be able to get back in the lab and have the CLEAR team help us finish sediment sampling analysis. So we have some of that yet to do, hoping by the end of 2020, early next year, that we'll be able to release those results. But we do have some information. So the sampling that we did, I'll just mention this as an example. So this is our surface water site. Just wanted to remind you where those surface water sites are so that when I show the sediment sites, I won't go through every location, but just Lunenburg, LaHave River as an example. As mentioned, we wanted to collect data at adjacent shoreline sites. So we, in 2018 and 2019, we collected data. Sorry, this is slightly wrong. The hotspot data was just collected in 2019. The data collection overall was all sites. So in 2018, we collected data at Oxnard's, Hurdles, Mosier's, Crescent, and Risser's Beach. And then with the information that we had and the data analyzed in the first year of data collection, we went back to some of the higher quantity sites. So those were Oxnard's and Hurdles Beach. So those are our hotspot sites. And more information on that hotspot analysis and the results that we found will be released shortly. But just to get an idea of where sampling was taking place, if we had surface water samples in Hartling Bay, we really wanted to understand more, okay, what are the plastics that are ending up on the beach at Hurdles Beach? So just having close comparison between the two sites. We also utilize CLEAR's method for shoreline sediment survey. And by doing so, we had 100 meters of a shoreline, measured that out, randomly selected 4 transects, 1 meters by 1 meter, and we had high tide, mid-beach, and back beach samples taken. So a total of 12 samples were collected per site, sample bottles, so that we could get an overview of the plastics at that beach. So this sampling method is quite similar, I believe, to NOAA's sampling method, but we kind of rinse the sample, stir it up, and allow it to settle. And then the microplastics that we're looking at are floating plastics. So those all float then, and we rinse the top into, again, our sieve, and rinse that sieve into a sampling bottle. And we get an idea of the plastics in that area. We're skimming just the surface of the sand, so just the top portion of the sand. So our results, just to show kind of an example, in the shoreline sediment results from our area, LaHave River, Islands, and Lunenburg. What was interesting, we're seeing a lot more threads and less fragments. So I think that that's, especially for our localized sites, for the knowledge of the region that we have in the South Shore of Nova Scotia, there is definitely a lot of fishing activity, offshore fishing activity, and that can kind of accumulate, and because of ocean currents, then make their way onto shore. We went sampling at Hurdles Beach, or went for a visit to Hurdles Beach before we were going to do sampling after Hurricane Dorian, which happened in early September of 2019, and noticed a ton of fragments, a lot of fishing gear. And so any of that kind of activity and a lot of the mixing and strong ocean currents that were occurring and wave action, there was a lot of debris that was left there. And it was quite evident that a lot of that was from fishing materials, as we can see in the categories here. So we don't have chemical composition analysis done on our sediment sites. We were just doing that for our surface water sites, but this provides a bit of an overview of what was conducted there. So to wrap up, I want to provide kind of enough time for some Q&A, but I just wanted to kind of go over what our next steps are. So as I mentioned, we have a final report with the surface water data available on our website, coastalaction.org/microplastics. We will be adding the FTIR results as well as the shoreline sediment results soon as that comes available. FTIR will be available very soon and added to that report. We're also working on a peer-reviewed article to submit to Marine Pollution Bulletin in collaboration with all the project partners over the past few years, hoping to do so in the summer of 2020 and have kind of a baseline understanding of plastics, the methods we used for other researchers, which can be useful hopefully for others who want to take this on. And we have new proposed projects. So the work doesn't stop here. For microplastics, we are proposing new sites for data collection in the Gulf of St. Lawrence and the St. John River watershed with new partners in PEI and New Brunswick, utilizing the knowledge and experience we gleaned over the past few years, and looking at surface water data collection as well as blue mussel impact studies. So looking at the particles that are being ingested by blue mussels, a very economically and environmentally important species for Atlantic Canada, and looking further at that. I also work with the Microplastic Working Group, which is made up of many different members. I am one of the co-chairs, and we are planning many different things, but trying to just coordinate a bit better on our efforts around research, but also education and some of the prevention initiatives around microplastics. And through that work, I'm also hoping to do our Nova Scotia focused microplastic project, which will work on expanding lab capacity. So as Max and Claire know, they've been given a lot of work, and we don't have a lot of capacity in Atlantic Canada to quantify and analyze plastics in the way that we should in order to better understand this issue. So that is a data gap that is needed and kind of a resource gap that we're hoping to explore further. And this will also include some data collection at new sites on the Atlantic coast of Atlantic Canada, or sorry, Atlantic coast of Nova Scotia, looking at Chester, Mahone Bay, and some new sites for collection there. And lastly, one other kind of next step is a workshop. So this workshop series, the first was supposed to be at the end of this month. It is funded by MEOPAR, and in partnership with Dalhousie, Dr. Tony Walker has been very helpful in helping us develop this workshop. But the real point of it is just to utilize the experience that we were able to get over the past few years working on this issue, working with Max and her team, and delving into effective methods for research, and trying to share that with others so that we can collect more data and understand the issue better. So it involves building the trawl, the LADI trawl. We'll be going out and doing some in-field sampling and actually on-the-ground collection and see how that works. And then it's an opportunity to kind of bring your project to life, network with others. This one that we had planned for the end of the month, we had about 10 participants, which was exactly what we were hoping for, just kind of a small group and enough that we could have a couple boat trips. But it was made up of and I'm hoping that people can still attend whenever we do have the workshop, possibly this fall, if things open up. But really is an opportunity to learn these methods, and we have individuals from government, municipalities, NGOs who are interested in taking on more of this work. So if you'd like to chat more about this, we're hoping we can put on more workshops like this in the future. And I want to say again, thank you. This is a great opportunity to say thank you again to Environment and Climate Change Canada for funding this 3-year project, to Clean Annapolis River Project for their hard work and data collection over the course of the project, ACAP Humber Arm as well, and Clear, and Dr. Max Lebrun and her team. Just thank you for being involved, and I'm excited for the next steps and what's next for us.
Thank you very much, Ariel. That was a really informative presentation. I really enjoyed it. And we already have a number of questions coming in. Just a housekeeping question first. A few people have been asking, will the slides be shared? We will share the recording with you. And Ariel, I'll leave that up to you. Would you be comfortable sharing a copy of the slides?
Yeah, for sure. Maybe a PDF version can be shared to whomever is interested.
Perfect. Yeah, so we can send that out. It'll be, like I said, potentially up to a week after this webinar. You'll receive an email, and it will have a link to the recording. Ariel has provided us with a couple of links to reports that I know people have been asking about as well. So we'll include those all in one kind of package for you, and feel free to distribute those to your contacts who might be interested in this area. It's really great to see all the work that's been done, and I'm just going to head into the questions because there are quite a few. Norheen has asked, why did you choose to analyze with FTIR, not Raman? And my apologies if I'm not pronouncing that correctly. RAMAN.
Mm-hmm. We were originally, when we created the project plan and developed the project, we decided to go with FTIR because of the connection we knew at Surface Science Western, and because of some of the research we were looking at. So we just decided to go with that analysis based on kind of the availability to us. And we were looking and hoping for FTIR possibilities in Atlantic Canada, but that hasn't been, we haven't really had time to pursue that, and that's kind of our next step, because we'd love for the chemical composition to be done more on a regional scale, potentially at one of the academic institutions in Atlantic Canada. But we just kind of went based on availability and the research we were looking at.
Yeah, thanks for that, Ariel. Actually, speaking of chemical composition, we have a question. When you refer to chemical composition, are you referring only to the polymer, or did you look also at the additives?
Yeah, so we have a full report on this, and I will be delving more into it, but it's mostly looking at the polymer itself. There were a couple notes provided to us about additives, particles. Chemical composition was done per tiny particle, and they would note, okay, it's polypropylene, and then a couple notes were provided to say potential additives such and such. So yeah, there was a little bit of information, but I think the focus was on the polymer type.
Excellent. We have a note. Thank you for the presentation. It was great. How in your analysis do you correct or control for potential plastic rope fragments that may originate from the trawl tow rope? So do you eliminate certain colors, for example?
Yeah, that's a great question. Part of kind of the master data sheet that CLEAR provides us for when we're out doing our sampling is to make a note, what are the trawl rope colors? We do a contamination sample of everyone who is on the boat, so we're just kind of taking off, taking off the particles that are on our clothing and putting that onto a contamination sample, which is then, it's just a double-sided tape on a petri dish, which is then sent to the lab so that they can make sure that they're comparing those particles with what actually was in the sample. Yeah, so that is an important part to control contamination for sure.
Yeah, I really like the low cost, like the efforts that you've made to keep these materials low cost, so that different communities can follow these methods too. Like you mentioned, the Gatorade bottles and the LADI Trawl, and that's really neat. Okay, great. So a couple more questions. Rebecca asks, what was the standard deviation of the FTIR results? And perhaps this is going to be something again that is delved into more in the report.
Yeah, it is. I actually don't know the specific standard deviation, and thanks for joining, Rebecca. I will check into that and let you know as soon as I can.
Thanks, Ariel. Um, oh, lots of questions here. Thanks everyone for participating so much, and feel free to follow up if you have further related questions here. Okay, so Wen asks, when using the plastic bottle of fresh water to wash hands and the things collected, will that bring a bit of microplastics into the sample, since it is a plastic bottle?
Yes, that's a good point. So there is potential for contamination kind of through every part of this process, unfortunately. And we want to make sure that when we're kind of communicating the methods we use, that it is mentioned that we used plastic bottle. We use plastic bottles for our shipping, so the actual sample was in a plastic bottle, firmer scientific bottles, but also in those as well. So there is potential for contamination. I mean, there are plastics in the fresh water, tap water, in bottled water. So it's kind of hard to avoid, but that is mentioned kind of throughout the process and in our reporting.
Fantastic. Audrey has a question on plastics composition. So she says, does the unknown commercial plastic contain polylactic acid by any chance? And she says, this is the so-called biodegradable plastics used in single-use plastics a lot.
Yes, that's correct. I believe it is. I'm going to look back at that graph, and that is available in our final report, so you can check it out to see. But as I was just looking at it in this past week, I believe that is one of the uncommon commercial plastics.
Mm, okay. Let's see, a few more questions here. How did you quantify the microplastics sampled from sediment, and which equipment or method did you use?
So this analysis was done by Civic Laboratory for Environmental Action Research, and I was there to kind of help and learn how that process is done, but it's very similar to what is done for the surface water. It's visually done. There's a contamination sample next to the microscope. You visually quantify what you're finding. It's a little bit more difficult than the surface water because there is um, quite a bit more sediment. But the method we use, we're not actually collecting, we're not looking at a sediment grab. So you're not grabbing a lot of mud and dirt, which you may do with like a benthic sample or kind of a core sample. We're actually grabbing the top of the surface of the sand, rinsing that with water and letting it settle. So just a reminder that then only hopefully, only really we're getting floating debris. So you do definitely get some, bark and seaweed and that kind of thing as you would expect, but we're not getting a ton of mud to sift through. So you're getting what is floating to the surface, and then that is sieved through the sieve. So yeah, hopefully that describes it a bit further.
Yeah, that seems nice and clear. Oh, sorry, we're getting a bit of an echo there. Okay. So another question, could you share some of the reasons why you use LADI compared to other instruments like Avani?
Yeah, I'm not familiar with Avani, but I will look into that. But the reason we chose to build our own trawl and use the LADI manual was because of our partnership with Clear, because of our kind of new to the scene on the microplastics when we came into this about 4 years ago, and we assessed kind of all of our options. So we did really look into utilizing the Manta trawl, which we could have rented and shipped between our partners. It's a big kind of metal trawl, quite heavy, but the cost for just even rental and shipping because of its weight would really kind of eat up our resources. So once we looked more into the LADI Trawl manual, that we were able to build it ourselves, fix it ourselves, and each have our own with the resources provided from our funding, it was kind of a no-brainer for us. So we're definitely quite attached to that method.
That's great. And actually, sorry, again, there's a bit of an echo, but I see that Max Liberon has joined us, and she notes that the Avani trawl is specifically for very high speeds and is much more expensive to build. And it can also be heavy, like the Manta. So
Okay, yeah.
yeah, I can
Yeah,
see.
that definitely helps answer that a little bit more. Thank you, Max.
Yeah, thanks, Max. Much appreciated. Um, We have a question from Ian. Does the analysis of plastic type and chemical composition help understand how much plastic is coming from municipal waste or land runoff generally versus fishing, for example? That's a good question.
Yeah, that is the hope. So really, we're looking at trying to understand the sources better. So when we look, we may have kind of a general idea of that when we look at the type. The chemical composition helps confirm that even further. So if we believe that a lot of what we're seeing, we need to make sure we're connecting it with our knowledge of the area as well. So if we believe a lot of those fragments or beads may be coming through, or fibers, may be coming through our municipal waste, through our washing machines, through straight pipes and sewage outflow, that can help kind of confirm that or provide more data on it. Um, and then if we're seeing those threads, that is definitely an indicator that there are rope or netting from fishing activity and gear. So our hope is that with further kind of look at this, we can make some assumptions, we can make some kind of statements about what we might see, obviously with some questions still attached to that. But yeah, our hope is to really connect type, chemical composition with source.
Thanks, Ariel. A few more questions coming in. I think you might have answered this in your presentation. There's a question about the size range of the microplastics you analyzed. So smaller than 5 millimeters and larger than what?
Yeah.
Can you remind us?
So we do have them kind of categorized. Most of what we're seeing are less than 5 millimeters, but now I think Max might be helpful on this. We're not, there's only a certain point that you can really see visually detecting these microplastics. So in nanometers in size, we're not really seeing those tiny little plastics. But then I think it's 2 to 5 millimeters in size. We're detecting that kind of tiny range. And then there's 5 to 25, which is kind of the mesoplastic, and 25 or greater, which are the macroplastics. So our data actually shows those size classifications.
Okay, that makes sense. Meredith asks, I'm wondering if you could further explain why in your sampling protocol you decided to go with the plastic bottles for sampling and hand washing instead of a glass bottle.
Yeah, this kind of to go along with the research that we have seen, and kind of the advice we got from experts on this, it definitely accounts for some contamination and potential contamination. In terms of rinsing, we kind of needed some kind of plastic for the rinsing of the sample itself and processing the sample. If we did go with a glass, because of the volume of samples, there's potential for breakage, and there is quite a higher weight, and so the resources and the costs associated with that is kind of the reason. We do have to account, obviously, for contamination coming from all sorts of avenues, and realizing that that's potential.
Right. And I see Max also responded that 0.5 millimeters is the lowest size for accurate visual analysis for the microplastics. And she says it's why there aren't so many microfibers in the results. That's the lowest we analyze this way.
Right, yeah, microfibers can be very tiny. Mm-hmm.
Okay, thanks.
Thanks, Max.
Yeah, and a couple of questions from Marie. When using the trawl, what method did you use to estimate the volume of water passing through the trawl?
Yeah, I'm actually just getting the statistical analysis on this. We have someone who is doing that work for us. So I'll have more data on the methods, the stats methods used. But we're looking at the area of, so knowing the size of our mouth of the trawl, and making sure that we not only have measured that during building, but measured again, so that we can send that to our stats person. And then determining the area. So we're looking at the total area and then the total area sampled by the trawl. So that's kind of the method used to determine how much we're actually getting. We also utilized a flow meter. So we have flow meter results. So we took the reading before the meter goes in with the trawl. It's on the mouth. And I don't know if I have a photo that showed that, but there is a mouth, there's a flow meter attached to the mouth that's taking that reading as well. And that is in the data that was sent to Clear as well.
Perfect. And in the photos, there was quite a bit of foaming. Did that affect the microplastics collected?
Um, I don't know if it affected it. It often kind of would build up into the cod end. So that's really where we're getting our sample. But it never overflowed the cod end. So and I'm just speaking from our experience sampling in the LaHave Islands area. So sometimes there was foaming, but that was always, once we're processing the sample, it didn't go any further above the cod end, kind of overflowing the sample. So we didn't find that it was an issue.
Perfect. A couple of more questions. Oh, Marie says, thank you for the answer and your presentation. It would be interesting to compare. Um, let's see. We have a question about biofouling. So during the practice, do you ever have issues with biofouling?
Um, no, we didn't have any issues with biofouling. Yeah.
Okay, great. How did you deal with the fact that heavier polymers need hypersaline water to float and may have been missed in the flotation conducted in the sampling sites using seawater?
Yeah, so we're looking specifically at Newston floating plastics in this study. It is quite evident that there are plastics that fall to the bottom of the sea floor or an aquatic environment, so that's benthic plastics, and also within the water column itself. So we're not accounting for those plastics, and additional study would need to be done. The process for collecting microplastics has really been focused on surface water plastics because most of it is floating. However, we are missing some that would be kind of settling on the seafloor as well, and in the water column. Our original plan was to look at benthic environments and take a sediment grab, which we may do in future studies, but we ended up going with adjacent shoreline due to kind of the materials and the method for analysis as well, because that's quite in depth when it comes to analyzing and sifting through sediment.
Thanks, Ariel. And a note from Marie that she noted it would be interesting to compare volume versus area results. So that's just something that didn't quite come through in her last comment.
Yeah, for sure. Hoping to do that with once we do stats on the area, and then utilizing the flow meter volume as well. So yeah, thank you, Marie.
Thanks everyone for all the really interesting and engaging questions. We do have a couple of questions on participating in the workshop, and I know Ariel, you mentioned that that's the planning is happening, but of course with the situation with COVID-19, you have to look at what's possible to do. And healthy for everyone. So I'm sure you can keep us posted as the workshop plans get made. And I do want to wrap things up by just thanking you once again, Ariel, and thanking Coastal Action for sharing these results. It's obviously something that people are really interested in, and we really appreciate you taking the time to do that. I'm seeing a lot of comments in the chat, people saying thank you, and that the presentation was really interesting. So I just wanted to share that.
Great.
Um, we do hope that you enjoyed today's webinar. You can also follow up with us, if you have further questions. As I said, we will be sending out the recording and a PDF version of the slides and some links to Coastal Action's work. Really exciting, I think, what you've done, Ariel, and the plans that you have for the future. And, you particularly touched on some capacity gaps. So I think that's something that, we're eager to help with, help address. Please follow us on Twitter and check out the events page on our website at meopar.ca, and do check out Coastal Action's website for more information on their work. Our next webinar is going to be held on May 13th, and the topic is Living Through and Coping with Stressful Times, a session for graduate students. So a little bit of a different topic, but an important one at this time. So once again, everyone, stay well and take care.
Thank you.
Thanks.